right, here we go. So guys, watch what happens. So when you're multiplying these together, hopefully you FOILed it all out and distributed, right? But something weird happens. After you FOIL, guys, what's going to happen to a negative 20i and a positive 20i? They're going to cancel out. So the i's have canceled. The imaginary part has literally canceled out. And now you're left with 25 minus 16i squared. But we know that negative 16i squared is really negative 16 times whose I squared? Negative 1. And that's really going to become positive 16. So at the end of the day, you're really just left with 25 plus 16. And what real number do you get? 41. So it's weird. It's like, wait a minute. I just multiplied two complex imaginary numbers together, and I got a very, very real number answer. And it's like, well, we did that yesterday, and we didn't get a real number answer. And you're right, because the things that I asked you to multiply together today are special, and we're going to talk about that in 2 seconds. But first, let's finish this one. Same thing happens over here. You multiply these two complex numbers together, you end up here, but what's going to happen to 14i and negative 14i? They're gonna cancel, and again, you're just left with 4 subtract 49i squared. But we know that's negative 49 times negative 1, and what's negative 49 times negative 1? Positive 49. So you're just left with 4 plus 49, and you get a very real number of 53. So it's like, wait, why is this magic happening today and not yesterday? Why are we multiplying complex numbers today and they're becoming real numbers? Well, the reason is because it's what I asked you to multiply together. If you look at the start of this problem, look at the complex numbers that I asked you to multiply together. They're almost the exact same number. The only thing that makes this number different from that number is the middle sign. This one is 5 plus 4i. This one is 5 minus 4i. And we actually call that something in math. When that middle sign is different, we call that a conjugate. These are actually complex conjugates. The only thing different between them is their middle sign. And when you multiply conjugates together, all that bad I stuff is going to cancel out. And it's just going to leave you with a very, very real number. Look over here. I gave you negative 2 plus 7i, and I asked you to multiply it with negative 2 minus 7i. The only thing different about these two complex numbers is that middle sign. They are conjugates. And when you multiply complex conjugates together, the answer is always real. The bad stuff will always cancel out. So now that we know how to multiply complex numbers and get a real number as our answer, we're going to use that in the division today. Remember I told you yesterday, the division of complex numbers isn't really going to feel like division. It's different. And that's exactly what we're going to have to do. We're going to use conjugates to get our way out of the division, all right? So let me give you guys your notes, and then we'll see how easy today is going to be too. This is not hard. It's just annoying. It's not as nice as the ones we did yesterday. This takes a little bit more time.
Wait, I thought you said that's the only thing that's
This is. Well, I said I still have to do division. I'm saving division for its own day, but it's just operations with complex numbers. Adding, subtracting, multiplying, and dividing. What's up?
I forgot to do division. Like I'm not even trying to do it.
But you're not gonna, it's not going to be division, so don't worry. Do you guys remember when you were asked in elementary school to divide fractions? Do you guys remember keep, change, flip?
Yeah.
Right? You keep it, you change it to multiplication, and you flip over the second fraction. It's the same thing. There was no division of fractions. It turned to multiplication. Same thing's going to happen here. This is going to turn into multiplication, okay? But it's not, we're not going to call it that. All right? So before we see that, no, we're not going to keep, change, flip. I was just making an example that when we did keep, change, flip, that the division turned to multiplication. This will turn to multiplication too. That's it. We're not flipping anything. We're not doing that. All right, so here we go. So before we start the division, let's just review what we know about complex numbers. Let's just keep it fresh. All right, we know that we get complex numbers, imaginary numbers, by taking the square root of a negative number. And the imaginary number I should come out. We know that I squared is equal to who? Negative 1, right? A very real number value. And then we know if we take the square root of both sides, I himself is just the square root of negative 1. Beautiful. Okay. Yesterday we got introduced to basically two kinds of complex numbers or imaginary numbers. There are going to be pure imaginary numbers, and those are numbers that can be written in the form like BI. So if you had negative 3i, that's entirely imaginary. If you had positive 8i or I by himself, those are pure imaginary numbers. They don't have a real number part to go with it, all right? And then we saw there are complex numbers. Complex numbers are numbers that can be written in the form a plus bi, where a is a completely real number and bi is your imaginary number. So just like in the warm-up, we had what, 5 plus 4i? That's a complex number. He has a real number, but he also has an imaginary number part, all right? Or like the warm-up, negative 2 minus 7i. That's a complex number. He has a real number, negative 2, but he also has that imaginary part, negative 7i. And then if you're ever working with complex numbers, they usually always want you to write your answer in standard form of a complex number. And that's just a plus bi form. That just means they always want the real number first and the imaginary number second, always in that order. Okay, well, we're gonna have to work with conjugates today. In order to work with the division, we have to be able to create and find a conjugate. It's super easy. If you're gonna create a conjugate, you just have to change the middle sign. So if you have a complex number in the form a plus bi, his conjugate will be the number a minus bi. You just have to change the middle sign to the opposite to create a conjugate. All right, so in the warm-up, you were given the complex number 5 plus 4i. Then you were asked to multiply it with his conjugate, who was 5 minus 4i. Just change the middle sign. They are conjugates. And if you multiply them together, all the bad I stuff will cancel out and you'll just be left with a real number. All right, just like the warm-up, you were given the number negative 2 plus 7i, and then you were asked to multiply it with his conjugate, which was negative 2 minus 7i. Just change the middle sign, and they will multiply to a very real number. All right, let's say you were given the complex number 9 minus 3i. Who's his conjugate? 9 plus 3i. Just change the middle sign. It's that simple. Only the middle changes. All right, if you were given the complex number negative 10 minus I, who's his conjugate? Negative 10 plus I. Nice and easy. Just change the middle sign. And guys, they can even be fractions. If you had the complex number 1/2 plus 3/4 I, who's the conjugate? 1/2 minus 3/4 I, and you're done. All right, so you're gonna have to be able to find a conjugate and use it. All right, so here's what's gonna happen. I wish I had left this in a better spot. When you multiply complex conjugates together, we have just seen the answer is always a real number. For this reason, complex conjugates will be very helpful when we're dividing complex numbers. When you are asked to divide complex numbers, guys, something's going to happen. It's not going to feel like division at all. We don't really want to divide by a complex number. We want to divide by a real number. So really, we want to make a real number who we are dividing by. So division of complex numbers isn't really dividing, but really it's something called, now let me give you the fancy words, something called rationalizing your denominator. You are really going to rationalize the denominator. That's what a math book would tell you to do. But basically all it means is, guys, you don't want to divide by I. You don't want to divide by something complex. You want to divide by something real. So really, you're just getting I out of the denominator. You are making the denominator a real number. All right, so that's really what you're doing. You're getting I out of the denominator. You are trying to make the denominator a real number, not a complex number. And we just know how to do that. We now know that I can multiply a complex number with its conjugate, and I can create a real number now. Okay? All right, so what I did is I wanted you guys to see what this was going to look like on Delta Math so that you didn't have to open it up tonight and be like, wait, what does this say? I wanted you to see it with me before I sent you home. So I created a Delta Math assignment to go along with these notes. Don't go on it. We're going to do it in our notes. But if you see this post later, it says notes, example, something, you do not do it. Don't do it. I just made it for the notes today. All right, so we're going to do examples on the back, so flip it over. So guys, I said in the directions, divide the following complex numbers, write your answers in A plus BI form. Delta Math directions are going to be different, but they mean the same thing. This is what it's going to look like on Delta Math. All right, so Delta Math is going to say, express as a complex number in simplest A plus BI form. So they're not even going to use the words divide. Your job is to take this division problem and express it as a simplest form of a complex number. So that's the problem we're going to do for example 1. This will be A, I believe. So let me write it up here, and then I'm going to go back to your notes. We're going to take negative 13 minus I, and we're going to divide it by 3 minus 5I. Okay.
The wireless mouse.
I know. I really should go back to that, but. All right, here we go. So this is example 1. So, like I said, it's not gonna feel like division at all. It's gonna feel like division at the very, very end of the problem. Right now, this is our goal. We don't want to divide by 3 minus 5i. I want to divide by a real number. So what can I times 3 minus 5i by that will make it become a real number? It's conjugate, 3 plus 5i. So we're going to multiply the bottom by 3 plus 5i. It's conjugate, because I know if I multiply conjugates together, they'll make a real number. Now here's the thing. Math has this rule though, whatever you do to the bottom of a fraction, you have to do to the, so if you're going to times the bottom by 3 plus 5i, you also have to times the top by 3 plus 5i. So guys, basically, this division problem just turned into a double FOIL. It's 2 FOILs that you have to do to get to the actual division. All right? So this is what worries me. Not that you won't be able to do it, but this is going to leave so much room for silly mistakes. So take your time and watch your signs. All right? Here we go. I'm going to do 2 with you, and then I'll give you 1 to do on your own. So just try to stay with me. You're going to have 1 to do by yourself. All right, anybody know what negative 13 times positive 3 is? Negative 39. Anybody know what negative 13 times positive 5i is? Negative 65i. Nice. All right, we're done with him. We took negative 13, we distributed him. Now we take negative I and distribute him. What's negative I times positive 3? Negative 3i. Nice. And then last, negative I times positive 5i. Negative 5i squared. Awesome. All right, now guys, what's a big old mess? We'll come back. Let's just get all the foiling out of the way. Just remember though, we're only trying to make the bottom become this beautiful number. The top's probably going to stay ugly. It's going to be a complex number. That doesn't have to happen to the top. We just want the bottom to become nice. All right, so here we go. The magic should happen in the bottom. What's 3 times 3? 9. What's 3 times 5i? 15i. So it's kind of like, I don't know, where's the magic, Hardy? This is when it should happen. In your second distribution, you should see the magic. All right, what's negative 5i times positive 3? There it is. Negative 15i. And then last, what's negative 5i times positive 5i? I squared. All right, there we go. So now we're left with the cleanup. Let's go to the top. He's not going to be as pretty as the bottom. The first thing I'm going to do is I'm going to get that negative 5i squared fixed. That's really a negative 5 times a negative 1. And then what's negative 5 times negative 1? Positive 5. So really we have a plus 5 at the end of this problem. So now let's combine like terms. Real numbers first, i's second. What's negative 39 plus 5? Negative 34. And then you're going to have negative 65 i's, but you took away 3 more. So how many i's do you really have? Negative 68 i's. Perfect. There's your numerator. It ain't pretty, but we don't need the top to be pretty. We need the bottom to be pretty. All right, now on bottom, I just can't take it. what's going to happen to 15i and negative 15i? Get rid of them. I's are gone. The imaginary part is gone. We know that negative 25i squared is really negative 25 times who? Negative 1, which is really what number? 25. So at the end of the day, guys, it's always the opposite of whatever number he started as. All right, so now you have 9 plus 25. What's 9 plus 25? 34. And there it is. So now it's a division problem. And the way you're going to divide it is you're going to do just like we did with the quadratic formula. You're going to split it. Create 2 separate fractions that we can divide one at a time. Are you okay? All right. So now we're going to take everything on top and give it its own denominator of 34. So take negative 34 and divide him by his own 34. Take this subtraction sign, throw it in the middle, and now you're going to take 68 i's and you're going to divide it by its own 34. And another reason we like to do this is, guys, they want the answer in a plus bi form. They want a separate real number and a separate bi number. All right, now we do the division. Guys, sometimes it's going to be dividing. Sometimes it's just going to be reduce, and then sometimes they might not be able to do either, and you just leave it alone. What's negative 34 divided by positive 34? Negative 1, subtract. Anybody know what 68 divided by 34 is? 2, so minus 2 times I stays. And there's your simplified, reduced a plus bi form. So that's nice. And guys, they ain't always going to divide to whole numbers. They're going to stay fractions sometimes. All you're going to be able to do is reduce. This is probably like a best case scenario. So you would go right to Delta Math, and you would type in negative 1 minus 2, and then I just use the I on my keyboard, and you're good to go. All right? All right, I'm going to do one more with you, and then I'm going to let you do the third one on your own, and then we'll be done. So let's do one more together. Let's try this one. All right, let's express this as a complex number in simplest a plus bi form.
Okay.
All right, so we got 7 plus 3i divided by negative 2 plus 6i. That's what they're asking us to technically divide. But remember, we ain't dividing anything, right? We want to divide by a real number. So your job is to get the bottom to become real. So what can I times negative 2 plus 6i by that will make it a real number? His conjugate, negative 2 minus 6i. And whatever you times the bottom by, do it to the top as well. So like I said, it's not really division, it's double FOIL. It's 2 multiplication problems. All right, let's be really careful on top. Guys, what's 7 times negative 2? Negative 14. What is 7 times negative 6i? Negative 42i. Perfect. All right, now we distribute the positive 3i. Watch your signs. What's positive 3i times negative 2? Negative 6i. And then last, what's a positive 3i times a negative 6i? Awesome. All right, leave it. We'll come back, right? The top ain't going to be pretty, but let's get all the foiling out of the way. This is where the magic should happen, in the bottom. All right, what's negative 2 times negative 2? 4. What's negative 2 times negative 6i? 12i, right? And it's cursed like, well, where is it, Artie? It's the second distribution. That's where the magic starts happening. All right, what's positive 6i times negative 2? There it is, negative 12i. And then last, what's positive 6i times negative 6i? Awesome. All right, so hard part's over. Let's go back to the top. The top ain't going to be pretty. Let's figure out who we got. I'm going to make this negative 18 times negative 1. So really, what number are we looking at? 18, right? That's really who's at the back. All right, so real numbers first. You have negative 14 plus 18. What number do we have? 4. All right, and then you have negative 42 i's, and you took away 6, so how many i's do you have? Negative 48 i's. Nice. All right, over. Now we go to the bottom. This should become a real number, or else you did something wrong. Either you multiplied wrong or you didn't use the conjugate. All right, what's going to happen to my 12 i's? Cancel. I'm really left with negative 36 times negative 1, which is really what number? Positive 36. So at the end of the day, you have 4 plus 36, which is nice. Now we can divide. Now we're dividing by a real number. So now let's split them and let's create our A plus BI form, and we'll divide our separate fractions. Okay. Well, guys, unfortunately, these ones aren't going to divide, so we're going to try to reduce, and if they don't reduce, you leave them. What does 4 over 40 reduce to then? 1/10. Say it again. If you want, I would, see, improper fractions, I always do as like 48 over 40. I would do 40 over 48, and then whatever it gives you, just flip it over. Because the calculators always want to take improper fractions and make them mixed numbers. So if you wanted to reduce this, I would put 40 on top and 48 on bottom, and then just flip over the fraction they give you. That's what I always tell the calculator to do. All right? And then last, guys, what's the biggest number that divides evenly into 48 and 40? 4, something bigger than 4. You could do 4, but you'd have to reduce again. 8. What's 48 divided by 8? 6. And then 40 divided by 8 is 5. Now, guys, here's the thing. Here's what you're going to notice. I want you guys to pay attention to this. Where you put the I has options. Math books are very specific that they want it in A plus BI form, where you can see A, you can see B, and then you can see I. So math books always take the I and write it next to the B. So they always put it as 6/5 times I. You can put it next to the fraction, or you can leave it on top. The only place you can't put it is where? It's not on the bottom. So you can put it next to it, or you can leave it on top. Either one is fine. Delta Math does not mark either one of them wrong. You put it in the bottom, though, that is not where I is. All right, we just work to get I out of the bottom, don't put them back. All right, so however you want to leave it. So I would type that in. And I double-checked Delta Math both ways. It takes it both. So I would go over to, I would do 1/10, subtract, oh, what did I do? Subtract 6, I'll leave it on top. 6 times I /5. And it says fine. All right, or you can put it next to it. All right, I'm going to ask you guys to do this last one on your own. I'm going to give you a head start, and I'll try and catch up. You guys try this one. Yep. Try that one. See if you can get that one. Because again, it's just all this foiling, but man, is there a lot of place to make mistakes. So be careful. One more. Last one. I'm going to give you guys a head start.
Thanks, OG.
Sorry.
What's up?
You ever tried to dominoes and you want to?
I did not. We're aiming for 100. Do this one.
Okay, I know how to do it.
I know, but if the more practice, the better off you're going to be on the quiz when we get our second 100 2 weeks in a row.
I don't know, that's asking too much.
I know, I am asking you off.
I can't be greedy.
Hey, you gotta try hard. You should like all this.
Right, double check that you at least chose the correct conjugate, that this is what you are multiplying the top and bottom by so that you're not wasting your time at all. Make sure that's who you chose, and then you can go back, and I'll give you guys a few more.
I already got it right.
There you go.
I got my right. I wish we had our tests on paper.
Well, unfortunately, I don't think that's how college is anymore. I think a lot of college is digital.
Yeah. What?
Yeah.
Remember the top, nothing special happens on top, the bottom should become a real number. Yep, perfect. And then just reduce them. Split them and reduce.
Let's do this right.
Yep. Now let's get the bottom number and then you'll split them and reduce.
Wait, Miss Hardy,
What do you got?
we boil these?
Yep.
Okay,
Top and bottom, it's like a double boil.
so you're double distributing?
Yes. Perfect, now split them and reduce. Hold on, 28 and 20. What goes in, if it's 28 over 20, it doesn't reduce to 1/4. What number, 4 goes into both. Like that part's right, and the second fraction is? And then if 20 was divided by 4, you would have 1 in top there. If you just reduce to 1. Yes, except, hold the phone. If you had a negative 24 and a positive 8, that would be a minus. And then you just split them and reduce.
Is that right?
Yep. Yes, good. Perfect. I'm gonna try and catch up to you guys, see a lot of good answers.
Dude, I need a minute.
Come on, G.
It's easy, I got it.
I'm gonna catch up to you.
I got it right there.
What?
I don't know. Well, when I go to school.
Yeah.
See?
You can reduce though.
Reduce you can't reduce an
Make sure your foiling was correct. Now, guys, the only thing that gets me worried is I'm always afraid that students are gonna be like, oh, look, Hardy, 8i and 8i, cancel. No, you would never do that over all of this addition and subtraction. Only multiplication and division can you start canceling stuff. This addition and subtraction, no, please don't do that. All right, now we start fixing stuff. I would say you wouldn't.
Wait, the test is on Thursday?
Thursday.
Why not?
Thursday?
Can we just have it on Friday? Because if we start something new on Friday.
No, because there's something I want to do on Friday before we start the next chapter, so it actually works out
This
nicely.
Thursday, so like April 7th, Thursday?
April 7th.
I think Wally's my favorite movie.
Guys, double check that you got the same numerator and denominator, and then now you're finally ready to divide. Now we split and reduce. Four goes into both, in both. So depending on where you want to leave I, do you want to leave it on top or do you want to write it next? But that's what you should get as your final answer. I saw a lot of good answers. Yes? All right, now guys, really quick, before we do this, tomorrow, well, first of all, you have homework on the dividing tonight that is due tomorrow. Yesterday's homework on adding, subtracting, and multiplying is due tonight. Tomorrow, I'm going to let you guys come in and just work on your Chromebooks, work on the review. So I'm going to let you review all of these operations, and then I'm going to quiz you on Thursday. I'm not going to stretch out another day. You just don't need it. This is nice, basic stuff right now. All right, so quiz will be on Thursday.